Welcome to this comprehensive guide on version control, specifically focusing on Git basics within Visual Studio and Unity. Version control is an essential system that tracks and manages changes to files over time, crucial for any development project, whether you're working solo or as part of a large team. It provides a historical record of every modification, allowing for greater control and collaboration. For beginners in programming and game development, understanding Git is fundamental for efficient collaboration and project management. It allows you to revert to previous versions, track changes, and work seamlessly with others, preventing lost work and streamlining the development process. This system is invaluable for maintaining project integrity and fostering teamwork. Git is a distributed version control system widely adopted in the software industry, enabling developers to manage source code and other file types effectively. It's a powerful tool for any project, from small personal endeavors to large-scale enterprise applications, offering flexibility and robustness in managing code changes across multiple contributors. Let's begin by understanding some key Git concepts. These foundational terms are crucial for grasping how Git operates and how it can benefit your development workflow. Familiarizing yourself with these concepts will make subsequent steps much clearer and easier to follow. First, a repository is a directory containing your project files and a complete history of their changes. Think of it as the central hub for your project, where every version and modification is meticulously recorded and stored. This repository is the core of your version control project. A commit represents a snapshot of your project at a specific point in time, capturing all changes made since the last commit. Think of it as saving your progress, but with a detailed message explaining what changes were made and why. Each commit is a permanent record in your project's history. Branches are separate lines of development, allowing you to work on new features or bug fixes without affecting the main codebase. This is crucial for parallel development, as multiple team members can work on different features simultaneously without interfering with each other's progress. It keeps the main project stable. Merging is the process of combining changes from one branch into another, integrating new features or fixes into your main project. This brings different lines of work together, carefully resolving any conflicts that may arise to create a unified and updated codebase. It's how individual contributions become part of the whole. Pushing involves uploading your local commits to a remote repository, making your changes available to others. Conversely, pulling downloads changes from a remote repository to your local machine, ensuring your local copy is up to date with the latest shared work. These actions are essential for collaboration and synchronization. Finally, the staging area is a crucial intermediate step where you prepare specific changes for your next commit. It allows you to select exactly what goes into each snapshot, giving you fine-grained control over your commit history. This area acts as a buffer between your working directory and your repository. Now, let's move on to setting up Git on your system. The first step is to download and install Git from its official website, git-scm.com. This installation provides all the necessary tools and commands to begin using Git for your projects, ensuring you have the core functionality in place. After installation, you'll need to configure your username and email. Open your command prompt or terminal and use these commands: git-config, global user.name, your name, and git-config, global user.email, your .email at example.com. These credentials identify you as the author of your commits, which is vital for tracking contributions in collaborative environments. Next, navigate to your project directory in the command prompt and initialize a new Git repository by running git init. This command creates the necessary Git files in your project, specifically a hidden .git directory, which stores all the version control information for your project. This is the first step to bringing your project under Git's management. With Git set up, let's explore the basic Git workflow. This involves making changes, staging them, committing, and pushing to a remote repository. Understanding this cycle is fundamental to effectively managing your project's evolution and collaborating with others. We'll walk through each step in detail. After modifying files in your project, you need to stage the changes you want to include in your next commit. Use git add file_name for specific files or git add to stage all changes. Staging allows you to carefully select which modifications will be part of the upcoming snapshot, ensuring only relevant changes are committed together. Once changes are staged, create a commit with a descriptive message using git commit, your commit message. A good message explains the purpose of the changes, why they were made, and what problem they solve. Clear commit messages are crucial for understanding your project's history and for effective code reviews. Finally, upload your local commits to a remote repository, such as GitHub, using git push origin branch_name. This synchronizes your local work with the shared remote version, making your contributions visible and accessible to your team. It's the final step in sharing your changes with the wider project. Visual Studio offers built-in Git tooling, allowing you to perform most Git operations directly within the IDE. This streamlines your development process significantly, as you don't need to switch between applications to manage your version control. It integrates seamlessly into your coding environment. Key features include creating or cloning repositories, committing and pushing changes, and managing branches. Visual Studio also provides robust tools for conflict resolution and history browsing, making it a comprehensive environment for all your Git needs. This integration enhances productivity and reduces context switching. To start, open your existing Visual Studio project. Then, go to Git, create Git repository to initialize a new repository for your project directly from the IDE. This action sets up the necessary Git infrastructure within your project folder, allowing Visual Studio to manage its version history from that point forward. If you have an existing remote repository, you can connect to it by cloning the repository or adding a remote origin. This links your local project to the shared remote version, enabling you to pull updates and push your changes to the central codebase. This is essential for collaborative projects. Managing Unity projects with Git requires some additional configuration, primarily to ignore unnecessary files. This is where the .gitignore file becomes essential, as Unity generates many temporary and local files that should not be tracked by version control. Proper configuration prevents repository bloat and conflicts. A .gitignore file specifies intentionally untracked files that Git should ignore, preventing temporary files, build artifacts, and other project-specific data from being committed. This keeps your repository clean and focused only on the essential source code and assets, avoiding unnecessary clutter and potential issues during collaboration. For Unity projects, a comprehensive .gitignore file is crucial. It typically includes directories like library, temp, obj, and build, along with various generated files such as .xproj and .sln files, which are often regenerated by the IDE. Ignoring these files ensures that only relevant project assets and scripts are tracked. Place this .gitignore file in the root directory of your Unity project to ensure proper version control. This prevents unnecessary files from cluttering your repository, reducing its size and improving performance, especially when working with large teams or complex projects. It's a critical step for efficient Unity development with Git. Unity projects often contain large binary files like textures and audio. Git LFS, or large file storage, is an extension that stores these files separately, improving performance and reducing repository size. Instead of embedding large files directly in the Git history, LFS stores pointers to them, making cloning and fetching much faster. Branching is a crucial aspect of version control, enabling parallel development and feature isolation. It allows multiple team members to work on different parts of a project simultaneously without interfering with each other's work, fostering a more efficient and organized development process. Understanding branching strategies is key to effective teamwork. The main branch represents the stable version of your project, serving as the single source of truth for deployed code. Feature branches are short-lived, used for developing new features without impacting the main code base, allowing for experimentation and isolated development. This separation ensures the main branch remains functional and deployable. Release branches are used for preparing releases, allowing for final bug fixes and testing before deployment, while hotfix branches address critical bug fixes in production, providing a quick way to patch urgent issues. Each serves a specific purpose in the development lifecycle, ensuring a structured and controlled release process. Git greatly facilitates collaboration among team members, allowing them to share code and track changes efficiently. This is where its true power shines, enabling distributed teams to work together seamlessly on complex projects, regardless of their geographical location. Effective collaboration is a cornerstone of modern software development. Key collaboration workflows include cloning a remote repository to get a local copy, proposing changes via pull request for review, and conducting code reviews before merging. These steps ensure code quality, facilitate knowledge sharing, and prevent errors from being introduced into the main codebase, promoting a robust development environment. While command line Git is powerful and offers full control, GUI clients offer a visual interface for performing Git operations, making them more accessible for many users, especially beginners. These graphical tools can simplify complex commands and provide a clearer overview of your repository status and history. Popular options include GitHub Desktop for simplicity, GitKraken for its visual appeal and powerful features, and SourceTree for a free, robust client. Visual Studio and VS Code also offer integrated Git support, allowing you to manage your repositories directly within your preferred development environment, further streamlining your workflow. To maximize your efficiency and maintain a healthy repository, follow these best practices. They will significantly improve your version control experience, reduce potential conflicts, and make collaboration smoother and more productive. Adhering to these guidelines will benefit both individual developers and entire teams. Commit frequently with small, logical changes and descriptive messages. This makes your project history clear and easy to navigate, allowing you to pinpoint specific changes and revert them if necessary. Frequent, atomic commits are easier to review and understand, contributing to a cleaner and more manageable codebase. Always use branches for new features and bug fixes to isolate your work, preventing disruptions to the main development line. Write clear commit messages that explain the purpose of each change, providing valuable context for future reference and for other team members. This practice is fundamental for organized development. Conduct code reviews to ensure code quality and identify potential issues early, fostering a collaborative environment and improving overall project health. Keep your repository clean by using a .gitignore file to exclude unnecessary files, preventing bloat and ensuring only relevant code is tracked. These practices are vital for maintaining a high-quality project. Finally, synchronize frequently by regularly pulling and pushing changes to stay up to date with the remote repository. This prevents merge conflicts and ensures everyone has the latest code, facilitating smooth collaboration and reducing the chances of outdated work. Consistent synchronization is key to a harmonious development process.